Hi, this is Unpeeling the 3D Printing News with Joris and 3dprint.com. I'd like to thank you all for joining us today, and yeah, thanks for being here, and I hope you enjoy this. We're This is a news update, essentially, of the relevant 3D printing news that's happening today. And what we have is a couple of stories for you today. We have 6 stories about 3D printing. One is Boeing and Northrup Grumman are joining AmForward. So AmForward is on the move, making quite a bit of news lately, and it's managed to snag 2 of the big companies in the whole defense realm. So that's a very good move for them. Uh, Again, AmForward is a compact, essentially, of big companies, mostly kind of defense-related firms, saying they're going to give business and give skills and knowledge and transfer capabilities to small to medium businesses in the United States with additive manufacturing. The idea is basically capacity building in additive manufacturing. So the US is better at 3D printing additive manufacturing and can deploy that technology better for its defense. Boeing is saying that it's targeting small to medium businesses for the request for quote packages using additive manufacturing. So that's great news, I think, for a lot of small to medium service bureaus and service companies and other companies that may be available for that business. Northrop is doing the same, uh, specifying that for a certain 50% of all the products, machinery, and manufacturing tooling, manufacturing process development using additive is going to go to small to medium businesses. So yeah, it's a good move, I think, for American industry. It begs the question, like, who's next, right? Are they going to get people like materials companies, steel companies, something like that, companies like Arconic? Or are we going to focus only on defense contractors? Um, what about Textron, for example, that's done a bunch of stuff with 3D printing? Now, also at the moment, we've got like companies that are members already of AmForward, like Honeywell, GE, Lockheed, Raytheon. These guys have made considerable investments in 3D printing. But what about companies that have not done as much with it? Companies that are not as aerospace minded. Think about, like, for example, Oshkosh, which is a truck manufacturer, or General Dynamics, which manufactures all sorts of land vehicles. Like these kind of guys, are they going to be interested in this? Are they going to look at a process like MELD or some of the WAM processes or some of the kind of like larger scale DED processes for metal, and they're going to conclude that that's something they want to invest in? Or is it only the companies that are a little bit ahead of the curve? So that's going to be interesting to see. The news number 5 is living walls in your home. This is a news story from the University of Virginia. And this has been done before in several different iterations in different ways by different teams over the years, different designers, researchers, but it's essentially it's 3D printing kind of a living wall. So 3D printing earth. Then in this case, they compact the earth with seeds and they print it into a wall, and then plants grow out of that to create kind of a living wall. Now, first off, this sounds kind of fanciful. And people have been trying to do this with lichen, and we've been trying to do this with mushrooms and different kind of mushrooms and things like that to make these kind of living structures. This is also quite difficult. The team here is saying that it's really difficult to balance right water, soil, and seeds, and then pressing it through the 3D printer. And it could seem a bit silly to do this, but I think really, if we're looking at something that is really reducing a wall, that's really reducing carbon footprint, that making a space very much more a natural space, this could really have legs. I mean, I'm not entirely sure it's going to be in your house, but imagine like a large corporate's kind of R&D area, or a lobby of a large company that's really to showcase its green credentials. For things like that, a living wall kind of concept would be very, very attractive to them. So, this is kind of stuff where we're like, nobody's really paying attention to it, but it's been going on for years that people have been trying to come up with these kind of living wall concepts. Maybe, there's a market for this. I'm not entirely, again, I don't expect whole neighborhoods to be printed with this immediately, but it could be very interesting for outdoor structures, for structures that want to blend in with nature, for some offices and things like that. So I think that was nice. Number 4 is Firehawk Aerospace, gets a Cincinnati MAAM. So MAAM is medium area additive manufacturing. It's FDM printer by Cincinnati, the machine tool builder. It's a 1 meter by 1 meter by 1 meter build volume. So, so that's for them as medium. Um, it's got a 500 degree extruder, 150 build plate, and 90 degree C chamber. So these kind of printers, we call them medium format at 3dprint.com. They have always been a kind of like a printer in search of an application because like there's regular FDM printers that can print components and also parts of components. And then there's giant printers that'll do form work and really large aerospace tooling. So what's the space for these kind of printers? Because on the one part, they have an enclosed chamber, right? The larger printers don't because, you don't not going to make a chamber 10 by 10 by 10 meters or whatever. So these have an enclosed build chamber, so they can really print unfilled materials. They can print really accurate materials. So there should be applications, but there have been very few at the moment, really comparatively to, I think, applications so far. And in this case, I think it's a really novel one that Firehawk has been working on for a number of years. And this is rocket fuel grains. So this is like a solid stage rocket that's printed, FDM printed fuel grain. And this could be potentially much more deployable in remote places and much more cheaper than other rocket fuel or rocket propulsion systems. So Firehawk is working on this. This is also, could be a really boon to the commercial space industry. It could also be a boon to like kind of other rocketry applications, let's say. But Firehawk has been working on that. And they put this on their LinkedIn. They said that they could build multiple hybrid rocket grains at once for their 1,000 to 3,500 pound designs. And then they're also looking at test stand parts, engine parts, flight vehicle parts, tooling, molds, and more. So to me, yeah, great resounding, application for these medium format printers. And also, yeah, it's we have Relativity Space, which is about to have a launch soon, hopefully. And they built their own printer and built their own technology about it. Like where Firehawk Aerospace is doing is they're developing a 3D printed fuel grain technology, but they're not necessarily making their own FDM printer. They're using someone else's. So it's a different approach. And I've been very curious about which printer they're going to be using for a while now. So this is interesting news for me. Number three is ASTM International's F42 committee, everyone's favorite committee, is starting to implement a new material testing standard for tensile properties of material extrusion filaments. Now, granted, this is probably something we should have done a while ago. But having said that, it would be really nice to have someone figure this out once and for all, and for us to all have a standard on how to test the tensile strength of different filaments. It's actually insane that we don't really have this, and everybody's making their own dog bones and doing different things. I've seen a number of projects go horribly wrong because of this, literally because of people not calibrating nozzle temperatures, for example, or people not drying a filament beforehand, or because it's insufficiently testing and calibrating their printers. So it would be really nice for somebody to figure this out. The person who's in charge of this, work item WK82320, if you're interested in following this, is Haibin Ning. He's an assistant professor at the University of Alabama. And well, yeah, I think it's great that we're finally doing this, but we should have done this a while ago, to be honest. But it's good we're doing it finally. Number two news item is Metafold. Metafold 3D is getting an investment. It got 500,000 Canadian dollars. Metafold 3D is a company we had the CEO on the 3D pod, and since then I've been completely fascinated by it. And it's a bunch of brilliant mathematicians who work together as mesh consultants, as their firm, and they ended up doing some things with 3D printing. And what came out of this is a thing called LightCycle. It's a cloud-based software tool that is a different way of looking at geometry and describing geometry, and that allows them to create highly complex kind of parts, lattices, TP mesh structures, things like this. The investors, Active Impact Investments, kudos to them because I think it's an absolutely fantastic company. I love the fact that these guys are mathematicians looking at our business in a completely new, fresh eyes kind of way. And I really think that lattices and TP mesh structures have seen a lot of interest, but it's really cumbersome to try and work through these structures and try to develop all optimal structures using current stage CAD and the limitations of files and things like that. It's great. Now, so this company, like, all for it, and I really think it's a wonderful investment. The only thing is, how do you take a product like this to market, right? How are you going to integrate with every CAD package? You're going to sell this as a separate standalone thing? Is it just a service where you get your geometry made one by one? I'd be very interested to see that. I think that's going to be a challenge. Um, okay, number one, the motionless printer has been developed. This is as in the Liebert Pub thing, out of the Manufacturing Journal. It's some research coming out of the School of Chemical and Biomolecular Engineering of Cornell. And essentially, what they did is they took an FDM printer and they fixed the nozzle and they fixed the build platform. And they have these high voltage switching points on the build platform. And they switch them in patterns to then influence the extruded PLA and ABS to be deposited in patterns. Now, this is one of these things where, and what they're going to do now is changing the voltage and changing the conductive points, the switching time between these points to try to, and the voltage to try to make new patterns, right? And this is one of these things where I'm on the one hand, I didn't know this was a problem. I didn't know this is somebody that would be interested in looking at this. We often see people trying to make either like a small incremental refinement to an existing process like FDM, or we see somebody trying to come up with like a completely new technology, right? Like the Xerox metal technology. And this is something completely different. We're taking an existing technology. We're using most of the parts of it, and we're going to we're going to kind of essentially create geometry in a completely new way. I don't know what you can do with this. I have no idea. I really don't. But having said that this is it really, I think it's fascinating, and I think it really points to us like doing lots of different technologies very differently through different upgrades and different ways of looking at that how that technology works. Anyway, so thank you so much for your time today. Have a great weekend. Have a great day, and thank you for watching.